Welcome back to the Explainer. Look, if you're trying to really master multi-cloud architecture, you are in exactly the right place. Today, we're tearing into the architectural foundations of API and integration patterns, specifically on Google Cloud Platform. We're going to take those heavy, complex cloud concepts and translate them into actual, actionable blueprints, the kind that help you build incredibly resilient systems. So, let's get into it. Here's the blueprint we're building together today. We'll kick things off with GCP API integration basics. Then, we'll look at the front door, our synchronous APIs, before heading to the back office for asynchronous events. After that, we'll tackle decoupling and scaling behaviors, and finally wrap it all up with 3 foundational architecture patterns.
All right, part 1, GCP API integration basics.
Okay, let's dive into this. Every single multi-cloud architect eventually runs headfirst into this core dilemma, right? How do you connect your microservices without accidentally building a super fragile, tightly coupled monolith that just crashes under pressure? Well, to solve this, we basically have 2 distinct paradigms of communication. First up is synchronous. We're going to call this the front door. These are your immediate, real-time conversations. You ask a question, you wait, you get an answer right then and there. On the flip side, we have asynchronous communication, the back office. Think of this more like a buffered postal service delivery. You drop a message in the mailbox, walk away, and just trust it's going to be processed when the system actually has capacity. No standing around waiting required.
Moving right along to part 2, the front door, synchronous APIs. So, when we're talking about synchronous communication, we're talking about that immediate, real-time traffic. This is literally where your system meets the outside world. And to manage all that traffic, GCP gives us some incredibly powerful managed entry points. We're talking about cloud endpoints and API gateway. These services act as the actual front door for any external users trying to access your system. They secure, monitor, and route incoming public internet traffic. It's basically a bouncer for your cloud. Before a user's request ever gets anywhere near your core application logic, it has to pass through this highly secure checkpoint. That gives you total visibility and control over exactly who is knocking on your front door.
Now, once that traffic safely makes it past the gateway, it hits your compute environment, usually something like Cloud Run or GKE, the Google Kubernetes engine. These environments run stateless containers and provide those immediate, sub-second backend responses your users absolutely demand. But, and this is a massive but, here's the critical warning. If you rely solely on these backends to talk directly to other internal systems synchronously, your architecture is still tightly coupled. Imagine if a downstream inventory service randomly fails. If things are tightly coupled, your Cloud Run front end fails right along with it, and your user is just staring at a really frustrating error screen. Not good.
Which brings us perfectly to part 3, the back office, asynchronous events.
Now, what's really interesting about this setup is how it solves that exact problem. That potential for a massive front door failure is exactly why we need the back office. Enter PubSub. This is a highly scalable messaging service that completely 100% decouples the senders of data from the receivers. It unlocks the absolute magic of fire and forget messaging. So your front-end service can just publish a message to a PubSub topic, immediately turn back to the user and say, hey, we're on it, and then entirely forget about the task. Meanwhile, a totally separate back-end service can just casually pick up that message from a subscription whenever it actually has the compute capacity to deal with it.
And to make all of this background routing actually work, we use EventArc. EventArc is an eventing framework that dynamically routes events from various Google Cloud sources right to your specific compute targets. Works hand in hand with PubSub to automate your entire back office with absolutely zero manual intervention. Honestly, you can think of it as the intelligent nervous system of your architecture. It just ensures that when an event happens over in one part of your cloud, the correct downstream service is automatically triggered to handle it. No bottlenecks, no waiting around.
All right, let's look at part 4, decoupling and scaling behaviors. So how do these 2 distinct worlds actually connect in practice? Let's follow a single data packet's hero's journey through a fully decoupled system. Step 1, a user calls your public API. Let's say they're checking out placing an e-commerce order. Step 2, Cloud Run receives this request via the API gateway, immediately processes the initial order validation, and authenticates the user. But instead of doing all the heavy lifting, like database writing and firing off confirmation emails right then and there, we move to step 3. Cloud Run simply drops an internal event onto PubSub for background fulfillment and instantly returns a success. Your order is placed, message back to the user. It's brilliant. Synchronous ingestion hands off beautifully to asynchronous processing.
Now, why go through all the trouble to design systems this way? One reason: zero-to-hero scaling. By decoupling that immediate user request from all the heavy background processing, we unlock some serious scaling potential. Cloud Run can rapidly scale up from literally zero to handle a massive sudden burst of user traffic right at the front door. Meanwhile, PubSub acts like a giant shock absorber. It seamlessly swallows massive throughput spikes without breaking a sweat. Your backend workers can just process that PubSub queue at their own steady, predictable pace, completely ensuring the whole system doesn't just crash under the weight of a sudden viral traffic spike. It's a total game changer.
And that brings us to our final section, Part 5, 3 Foundational Architecture Patterns.
We can really synthesize everything we've talked about today into 3 core blueprints. First, we have the synchronous public API. That's combining API Gateway and Cloud Run for those secure, immediate user-facing interactions. Second is asynchronous event routing, which leverages the raw power of PubSub and EventArc for robust, decoupled internal communication. And third, arguably the most powerful, is the decoupled hybrid system. This is where a fast public API simply drops events down to an internal PubSub queue, essentially giving you the absolute best of both worlds. So, the crucial point is, understanding these 3 structural blueprints literally gives you the toolkit to architect almost any modern, highly resilient cloud system on GCP.
As we wrap up this explainer, I want to leave you with a bit of a provocative question to challenge your current architecture. Are your microservices talking, or are they just shouting at each other? Think about it. If they are tightly coupled, blocking operations, and constantly waiting on each other in real time, they are shouting. And frankly, your system is brittle. But by utilizing these decoupled, asynchronous patterns we've explored today, you can orchestrate a smooth, highly scalable conversation across your entire cloud environment. Thanks so much for joining me for this explainer, and keep building smarter systems.